What's up, guys? Welcome back. Patrick here, and in this video, very similar to the previous example, we got to take these two functions here and express each of them as f of g in two different ways. So remember, f of g, that's the same as f of g of x, like that. So what we got to do is we got to state some cases where we could present two separate functions, but when we take f of g of x, we end up getting these functions here. So starting with part A, we got y equals ln x over 2 plus ln x. So one way we can do this is, notice we got ln x, and it's within a rational function. So what we can do is we could let g of x be ln x, and then f of x would be x over 2 plus x. Okay, does that make sense? So if f of x equals x over 2 plus x, that means f of an expression is that expression over 2 plus that expression. So we would end up having f of g of x, which is the expression in this case would be ln x, and then we would plug in ln x for this expression here. We would end up with that. So that there is one possibility for this. What would be another possibility? Well, we can kind of, I mentioned this in the previous example. We can maybe play around with changing the numbers up here. So let's say we have, let's say we let g of x be this entire denominator. So we could say ln x plus 2, or 2 plus ln x, both are the same thing. So if we let g of x be that, what would f of x have to be? Well, f of x, we know that there's going to be an x in, just an x in the denominator, because that whole expression has to go there. And then how would we get the ln x by itself? Well, we would have to take this expression and then subtract 2, so we'd have an x minus 2 up here. Does that make sense? So in this case, f of an expression would equal an expression minus 2 over an expression. Okay, so what we can do here is f of g of x, the expression would be ln x plus 2. So we'd have ln x plus 2 minus 2 over ln x plus 2. And then these 2's would net out to 0, so we'd end up with ln x over ln x plus 2, which is what we're trying to do. So this is another way to express this. And really there's an infinite amount of ways that we can really do this. So let's actually try one more way. I know it says 2 ways here, but let's push ourselves and try another third way. We could really let this g of x be any number. Let's say we have ln of x plus 10, for example. So if g of x is ln of x plus 10, what would f of x have to be in order for f of g of x to equal this over here? Well, notice that we're going to have to subtract this 10 to get the ln x by itself. So we know that up top here we're going to have x minus 10. And then in the bottom, we got to get this 10 to be a 2, so we would subtract 8. Like that. So that's another possibility. So if we plug in ln of x plus 10 for both of these x values, that's what f of g of x would be. Notice we'd end up with ln of x plus 10 minus 10 over ln of x plus 10 minus 8. And we'd end up with ln of x over ln of x plus 2, which is what we're trying to go for. All right, so again, an infinite amount of possibilities of what we can do here. Now, what about part B? We got y equals the square root of x squared minus 4 over x squared. How can we state an f of x and a g of x, where f of g of x would end up giving us this here? Well, one way is, notice that we got this whole function, x squared minus 4 over x squared, within another function, the square root of all of that. So we can say g of x is x squared minus 4 over x squared. Then f of x would just be the square root of x. So then f of g of x, we would plug in this entire expression for this x here. And we'd end up with that. So that's one way to do it. How else can we do this? Well, we can do, let's say we got f of x and g of x. We can let g of x be just x squared. Notice we have an x squared here and an x squared down here. And so we can rewrite f of x as, we can rewrite f of x, let me think here, sorry. Just kind of had a brain freeze there. So we would end up with x minus 4 over x, like that, right? So we would plug in x squared for these x values. F of g of x, f of an expression, if f of x is this, would be the square root of an expression minus 4 over the expression. So we'd plug in x squared for that expression. So we'd plug in x squared for this x squared for that x. We'd end up with this. What's another way we can do this? Sorry, I have 2 ways written up there, but I keep showing you more. But I just want to show you how there's an infinite amount of possibilities that we can do. Now, another way we can rewrite this actually is we could split up the fraction. Okay, so this and this are the exact same thing. So maybe another way is we can have f of x equals the square root of 1 minus x, and then g of x would be 4 over x squared. Right? That would be a totally different way to do it. We would plug in this whole expression for that x, and we'd end up with that. Okay, because again, this function is the same as that one. I just thought of splitting up these fractions because there's only one expression, a one-term expression in the denominator. So that's another way to do it. Another way, one more, I promise it's only going to be one more, is if we go back to this one, we can start playing around with this minus 4. So what we can do is, let's say we let x squared, let's say we let g of x be x squared plus 5. You could let it be any number, x squared plus any number. So we have x squared plus 5. How do we get to minus 4 from 5? We've got to subtract 9. So this would be x minus 9 over, how do we get the x squared by itself? We would subtract 5. Like that. So that's another possibility. If we plug in x squared plus 5 for the x's, x squared plus 5 minus 9, we'd end up with x squared minus 4. X squared plus 5 minus 5, we'd end up with just x squared. Right? So that is another possibility. So again, an infinite amount of possibilities for which you can answer these types of questions, or you got to take a function and then show it as f of g of x.